Good morning, and you're welcome to today's Signpost webinar. My name is Mark Gibson, and I'm the manager of the Teagasc Connected Programme. Wherever you're joining us from today, we do hope that you're keeping safe and well. The Signpost webinar series is brought to you in association with the National Rural Network, Food Drink Ireland, and Dairy Sustainability Ireland. In his address to the UN Security Council this week, David Attenborough said, "If we continue on our current path, we will face the collapse of everything that gives us our security, food production, access to fresh water, habitable ambient temperature, and ocean food chains." Self-Help Africa is a leading international development charity with an expertise in small-scale farming and growing family farm businesses, and is dedicated to ending hunger and poverty in rural Africa. And I'm delighted to be joined by Paul Wagstaff, who is Senior Agricultural Advisor with Self-Help Africa. Paul, you're very welcome to the Signpost webinar.
Thank you very much, and it's a great pleasure to have an opportunity to present to so many people who are experts in agriculture and experts in the sustainability of agriculture systems. So this morning I'd like to talk about agriculture in the tropics and how climate change will affect smallholder farmers. I'm going to focus on the smallholder farming sector rather than the commercial, the large-scale farming sector. So how climate change will impact on people's livelihoods, on crop production, livestock production, and the kind of interventions that an NGO like Self-Help Africa can use to try and reduce the impacts of climate change.
Excellent, excellent. And we're also joined by Pat Murphy, who is the head of the Teagasc Environment Knowledge Transfer Programme. Pat, good morning to you.
Good morning, delighted to be here.
Great, great. So Paul, could you tell us a little bit about your own history or your own background? I know you've been working in overseas development for quite some years now at this stage.
Yes, I started my career in tropical agriculture way back at the end of the 80s when I worked for the Tanzania Ministry of Agriculture as on the ground as an agricultural extension officer, much the same as you were doing, Mark, in your younger days. Mm-hmm. And I was working with farmers in Tanzania around Lake Victoria. Since then, I've moved across Africa, worked across East Africa, and worked a little bit in Asia as well.
Brilliant, brilliant. Okay, well, Paul, if we could ask you to maybe get your slides prepared there, and just while you're doing that, to let everybody know that if you have questions or comments for Paul at the end of the webinar, we'll certainly put those to Paul, but you can use the Q&A tab at the bottom of your screen to submit those questions. And also to remind everybody that today's webinar is being recorded, and a copy of Paul's presentation will be available on the Teagasc website afterwards as well. So, Paul, when you're ready, we'll just getting your slides organized there, and we shall talk to you afterwards.
Great, thank you very much. So, this morning I'd like to talk about the impact of climate change on smallholder food production in the tropics. So just to introduce ourselves, I work for Self-Help Africa, which is an NGO. We're based in Ireland and the UK. We have offices in Belfast, London, Shrewsbury and New York. And we're currently working in Burkina Faso, Eritrea, Ethiopia, Kenya, Malawi, Togo, Uganda and Zambia. So we're Africa focused. We don't have any work in Asia. And we are somewhat unusual as an NGO, as a development NGO, in that we are a mixture of commercial and non-profit organisations. So we're part of the larger Goethe group. So Self-Help Africa is the non-profit in the Goethe group. And then we have True Trade, which is an online trading platform for farmers to trade their produce in Africa, and Partner Africa, which is a consultancy company that audits supply chains for companies across the world. So they're working for some of the largest players in the food industry, auditing their supply chains to make sure there's no skeletons hiding in the closets. Okay, so I better start by a quick description of where the tropics are. So when we talk about tropical agriculture, where are the tropics? So the tropics are defined by the Tropic of Cancer in the north, 23 degrees, 26 minutes north of the equator, and the Tropic of Cancer south of the equator. The tropics are the area of the Earth's surface where the sun will be overhead at least once in the year. So no matter how long we wait, the sun will never be overhead in Ireland. So that's the geographical definition of the tropics. In terms of what's happening in the upper atmosphere, this is really crucial to understanding what's happening in the tropics. So if we look at the diagram here, we have the equator. So obviously most of the sun's energy is hitting the equator, and that creates a lot of evapotranspiration. So we have hot, moist air rising from the surface of the planet along the equator. As it rises, it cools, the moisture precipitates, which is why we get such heavy rainfall year round on the equator. We've now got sort of hot, dry air circulating the upper atmosphere. It cools, so we now have the cooler, dry air falling around 30 degrees north and south. Because it's very dry air, this is where we get the deserts of the world. So we get the great deserts of the Sahara in the northern hemisphere of Africa, the Kalahari and Namib in the southern hemisphere of Africa. And then, of course, if we went round, we'd have Arizona in the northern hemisphere, or if we went along the southern hemisphere, we'd have the Atacama and the Australian deserts. So, so this area here between the deserts and the equator is the area that I would define for tropical agriculture. So we have the high rainfall areas here on the equator, declining rainfall as we move north until we get to the deserts with zero rainfall. Not only have we got dry air sinking into the deserts, that air also pushes any moisture away from the deserts. So as we go north or south of the equator, I mean, on the equator it's raining pretty much every day of the year, but as we move north and south, we get into distinct rainfall patterns. This is a diagram from a very old agriculture textbook, but it's still one of the best diagrams I've ever seen for trying to understand rainfall in the tropics. So the hatched area is the rainy seasons. So along the equator, we have an area where we have pretty much rainfall throughout the year. See if I can change my pointer. Okay, so as we move to about 5 degrees north or south, we get into 2 rainy seasons a year. So these are the bimodal rains areas. As you continue moving north or south, those 2 rainy seasons, they usually be a long and a short rains, will start to merge into 1 rainy season. And then obviously if you continued off the diagram into the deserts, you get no rainy season. So it looks like an A, capital A. So the length, of course, of the rainy seasons will define which crops you can grow in the rainy season. So as many countries will have a long and a short, you'll be growing different crops in different rainy seasons. One of the challenges we have with climate change, we know that rainfall may, in some countries will decline, in others it will increase, and the temperatures will increase. But it's trying to understand when we've got a trend due to climate change, or when we're actually getting more of a pattern of variability. So this is the diagram that the UN Environmental Programme produced for Darfur. They were using this to illustrate how the rainfall is declining for Darfur, which is in Sudan. When I looked at this, I found something I thought was even more interesting with declining rainfall, and that was a change in cycles of rainfall variability. So what I think you can see on this is an area here, sort of pre-1955, when you had extremely high variability in rainfall. And then sort of around the sort of mid-1950s, it went into a period of relatively stable rainfall. We now seem to be moving into a period of variability again. Of course, this change between a period of very high rainfall variability and somewhat stable rainfall happened at independence. So you'd have to wonder whether the agriculture and livestock policies which were developed at independence are still appropriate for this period we seem to be moving into of highly variable rainfall. So I think this is, diagrams like this can actually show a lot more than just declining in rainfall. Okay. So climate change, we expect the temperature to rise in most of the countries in Africa. Of course, crops have their optimum temperature ranges, and then a threshold of the maximum and minimum temperatures they can survive. So the optimum temperatures would change across the growing season. So this is an example for maize where really the sensitive period is in the tasseling period. So anything above 30 degrees of the tasseling period, and you're going to see a dramatic decline in potential maize yields. So across Africa, smallholder maize yields struggle to reach 1 ton of maize per hectare. But with good agricultural practice, with good support, I worked with smallholders who managed to get 5 tons, and the record is 8 tons per hectare of maize. So you can produce good yields under smallholder agriculture, but once the temperature gets above 30 degrees, which is expected to do for most of southern Africa, you'll never reach those kind of yields. So you are really limited. One of the things we can try to think about is if we can understand rainfall patterns, we could try to time the planting of our maize so that we fit the tasseling with a cooler part of the year, so that the maize won't be putting on tassels in the hottest period of the year. It's important to note that for many crops, it's not so much of the daytime temperatures which are critical, it's the night. So for example, for wheat and Irish potatoes, Ceylon potatoes, we can grow those in some very hot areas. They're staple crops in the Middle East, because if you grow them in the desert, it may be very hot in the day, but it's cool at night. So you can grow them in very hot areas under irrigation as long as the nights are cool. And one of the things that's tended to be missing from the debate on climate change is what's happening to the temperatures at night. Obviously, we have similar issues for water availability. So in areas where rainfall is expected to decline, this will also have an impact on crop production. So here's a chart of water requirements for maize. Obviously, very high water requirements if you're in the semi-arid tropics, much lower water requirements if you're in the humid areas. And again, obviously mid-season is when maize has its highest water requirements. So can you adjust your planting pattern to avoid having the maize reaching its mid-season growth in a dry period or as rainfall declines? So a lot easier to do for commercial farmers. So you'll find commercial farmers, say in Zambia, will be planting their maize under irrigation in the dry season, and when the rainy season starts, they can switch off the irrigation. So their plants have reached mid-season as the rains are really getting underway. That's not much of an option for smallholder farmers. If we combine temperatures and rainfall, then we get the growing season. So here's an example for Magburaka, which is more or less in the middle of Sierra Leone. There's one rainy season a year, and obviously it's a wet country, it's a long rainy season. So we can see from this chart, although the rains will begin in the first week of April, the top line here is the rainfall, and then this line here is evapotranspiration. So although rain begins the second week of April, you're only going to have sufficient water for crop production once the rainfall exceeds evaporation. So really crop growth only really starts at the end of April as rainfall exceeds evapotranspiration, and then crop growth will end third week of November once rainfall falls below evapotranspiration. As we heat up the planet, of course, this line here for evapotranspiration will start to move upwards. As it moves upwards, that will reduce the blue period, the growing period. So that means we have to think about what crops we grow and which varieties we plant. Obviously, this is a wet country. I could have used a graph for a drier area. But one of the responses as NGOs has been to plant faster maturing, for example, maize varieties, and a lot of work has gone into breeding quick maturing maize varieties in order to fit in with a shrinking growing season. The challenge with this, of course, is that the longer a crop is in the field, the more it can photosynthesize, and therefore the more carbohydrates it can produce. So a quick maturing variety will never produce as much grain as a late maturing variety. As we heat up the surface of the earth, we're going to see a loss in soil fertility. Obviously, we'll evaporate more soil moisture. We're going to increase the rate of decomposition of organic matter in the soil and the oxidation of nutrients within the soil. And we risk entering a negative feedback loop. So as the soil organic matter oxidizes, and that's putting CO2 into the atmosphere, that's again warming up the atmosphere, resulting in more CO2 being released from the soil. It's a similar issue for nitrates in the soil, so nitrous oxides being released into the atmosphere. And of course, nitrous oxides are a much more powerful greenhouse gas than CO2. So we risk a negative feedback loop. And we're also seeing a loss in the beneficial soil organisms. So these are the macro fauna and flora, the earthworms and more the termites in the tropics, as well as the bacteria in the soil, the fungi in the soil, the mycorrhiza, which transfer nutrients from the soil into plants, the bacteria which fix nitrogen from the atmosphere. An increase in temperatures is going to speed up the metabolism of insects. And a very good example of this is the fall armyworm. We don't have it in Ireland, but I predict we will have it in Ireland inevitably at some stage. This is a pest from the Americas. It occurs year-round in Central America, and then it expands from Central America right up to Canada in the summer months. In Central America, it has a 1-month life cycle. If you go into sort of the Great Plains of America, it's a 2-month life cycle because it's cooler. So as we speed up, as we warm up the atmosphere, we'll be speeding up insect reproduction rates. So the fall armyworm arrived in Africa in 2016, and it spread like a plague from the Bible across Africa. It's it looks really dramatic when it enters a maize field, and it eats pretty much everything. Obviously, as we know in Ireland, any changes in rainfall will favour fungal diseases. And we're also going to see changes in vector behaviour, and the main vectors for viral diseases in crop plants are the aphids and whiteflies. Livestock will also be affected. So particularly for livestock, we're looking at heat stress, which is the balance between heat dissipation and heat production. So every livestock variety has its comfort zone, which is about 25 degrees for Friesian Holsteins. Once you go over the comfort zone, and for most cattle it's about 30 degrees, they start to reduce their feed intake, which of course reduces the amount of meat they produce and milk they produce. Each livestock breed will have a different response curve to increased temperatures. Obviously, the traditional livestock breeds for the Sahel will be highly tolerant. And if you look at a livestock breed from the Sahel, from the semi-desert areas, they tend to be quite scrawny, but that means they have a good surface to volume ratio. So they're quite good at dissipating the heat they produce through metabolism. One of the concerns we have is has been a lot of enthusiastic crossbreeding of traditional breeds with Friesian Holsteins in order to increase the milk production. Yes, this has increased milk production, but Friesian Holsteins are not very heat tolerant. So we do have the major concerns as to how these crossbreeds will respond to increasing temperatures. And of course, crossbred Friesian Holsteins will require large quantities of water, which may not be so easy to provide. You also need to think about fodder production, where you're grazing your animals on rangeland. We're going to see a change in the species of the rangelands and the digestibility of these species. Obviously, increasing CO2 levels. CO2 is a fertilizer, so that will increase the growth rates of some plants, but these will tend to be more of the weedy species, so not necessarily the plants which we want our animals to graze on. And as for crops, we'll see a change in the distribution of livestock diseases, particularly the vector-borne pathogens. Of which the main vector across the world, and particularly in the tropics, are ticks. Diseases like East Coast fever, corridor disease, babesiosis, anaplasmosis are all spread by ticks. We have mosquitoes, which spread Rift Valley fever, which is a zoonotic disease, which can spread into humans as well. One of the things I am working with Queen's University Belfast at the moment is looking at gastrointestinal nematodes in goats. Obviously, we know that the nematode levels increase in the rainy season, so we're doing modelling with Queen's on how nematode populations will change with rainfall, and if we can develop an app to help warn farmers when the high risk periods are. We're also looking at how to move away from the blanket treatment of goats. So the traditional advice is to deworm your herds and your flocks in the rainy season, and moving away to a test and selective treatment approach when you only treat those animals which are really showing severe symptoms of gastrointestinal nematode infections, in order to try and reduce resistance to the dewormers currently on the market. And even in Europe, I mean, we see an issue if you consider wild boar to be a vector for African swine fever. This is a viral disease that jumped from warthogs in Africa into pigs in Africa, moved through the Middle East. It's now in mainland Europe. It's spreading very fast because of the mild winters in Europe. Juvenile boar are surviving the mild winters. Boar populations have gone crazy, so there's a lot more wild boar carrying African swine fever. Increasing CO2 will actually fertilize crops. Some crops will be in a better position to take advantage of this. So potatoes, we know from research that Teagasc has conducted that increasing CO2 increases the number and weight of potato tubers. We're going to see longer growing seasons in the higher latitudes and altitudes. So the real highlands of Ethiopia are sort of 3,000 to 4,000 meters high. They're very cold. At the moment, all we can grow is oats and Irish potatoes there, but potentially you'll be able to grow a much wider range of crops. And in some areas, you have a reduced risk of frost. We do have frost in some unusual areas in Africa, in the western province of Zambia, which is actually one of the hottest and driest parts of Zambia. It will experience frosts. So we'll see a reduction in frost risks. And something as an NGO like South Africa, we're very, we do a lot of work on the links between agriculture and nutrition. You know, it seems sort of stating the obvious that we are what we eat, but actually it's very complicated. So trying to understand how agriculture impacts on nutrition, particularly the nutrition for children, is very complicated, but we are learning slowly. So a recent research report that came out at the beginning of the year predicted that higher long-term temperatures are found to cause a significant drop in child nutrition, and particularly this is for long-term, which is chronic malnutrition rather than acute malnutrition. And looking through the literature, it was quite a lot of concerns as to how climate change will impact on the nutritional content of crops. So low levels of micronutrient intake is one of the drivers for chronic malnutrition in kids, and particularly things like zinc, which is very important for young children. If young children are deficient in zinc, then they're more likely to get incidence of diarrhea, which clearly knocks back their growth, and iron, which is obviously very high levels of anemia in women across Africa and Asia. So the last thing we want to do is to see a decline in iron content of crops. So the research at the moment seems to indicate that it's really the C3 plants which will suffer most. So an increase in CO2 levels, it will stimulate an increase in photosynthesis and carbohydrate production in cereals, but only if there's sufficient phosphorus in the soil, and most tropical soils are highly deficient in phosphorus. And then we see an increase in CO2 levels, decreasing the levels of zinc and iron and proteins in the C3 grains and in legumes. So these are causes for concern, but still limited research on this at the moment. How can we respond to the changes in climate? Well, FAO in Rome has come up with an approach they're calling climate smart agriculture. They define three pillars of climate smart agriculture. First is ensuring we can sustainably increase agricultural productivity and incomes. Secondly, that we're adapting and building resistance to climate change. And thirdly, we're reducing or removing greenhouse gas emissions where possible. FAO was a 500-page book called the CSA source book. The new edition is now 600 pages, so plenty of information in there if you want to read up about it. The kind of activities, projects or technologies that SHA will be promoting range from agroforestry, as I mentioned earlier, quick maturing drought avoiding varieties, soil and water conservation, working at the landscape level on things like rangeland management, through to fuel efficient stoves and livestock and crop insurance. I'd like to give you a couple of examples here from our work. So this is a photograph from Zambia. This is a maize crop underneath trees. Those of you, hopefully it's a good quality photograph on your screens, and you'll see you've got a lovely lush maize crop here underneath the tree canopy, which will strike most of you as being odd. But if you look closely at the trees, you'll see there's no leaves on the trees. So this is a very unusual tree. It's called Fadeherbia, Alphidia. And whereas most trees put their leaves on in the wet season and lose their leaves in the dry season, Fadeherbia has a reverse phenology. So it has no leaves in the wet season and it puts its leaves on the dry season. Now it produces large quantities of nitrogen. It's a nitrogen fixing tree. And it's fantastic for intercropping with crops because it's not shading your crop, it's not competing for water with your crop, and the leaf litter is producing significant amounts of nitrogen. So in Zambia, research trials have shown that under a plot like this with maize growing under Fadeherbia, you're getting extra 3 tons of maize. Sorry, an extra 1 ton of maize under the Fadeherbia, with so 3 tons under Fadeherbia to 2 tons outside the canopy. And similar trials in Senegal on pearl millet found 2.5 times higher yield under Fadeherbia than outside. So agroforestry is one option. We can intercrop trees with crops like maize. Water, of course, if we're going to see an increase in surface temperatures and a possible reduction in rainfall, clearly we need to get more crop per drop of water. How can we do this? An obvious one is through drip irrigation, through high efficiency irrigation approaches. Drip irrigation is an obvious one. It's one of those save the world technologies, but it's proving to be very complicated in Africa. So drip irrigation is used in the horticulture industry everywhere in the world. It's used by smallholder farmers in Asia. Here you can see a farmer in India. But it really hasn't taken off amongst smallholder farmers in Africa. And it's a very, it's a puzzling question. I don't have the answer to this one, but I visited many agricultural extension officers across Africa. I visited NGO offices and looked behind the office to find stacks of unused drip irrigation pipe. So it should work, it does work, but uptake has been very low. More successful has been these simple pumps, just simple treadle pumps in the upper 2 photographs. Or here, this is from Zimbabwe. This is a simple water pump to extract water from the bed of a river during the dry season, made from a couple of bits of plastic pipe, the piece of reinforcing a bar and a wooden plunger. So this is all made locally. Really nice example of high efficiency irrigation from Pakistan. So this photograph was taken on the edge of the Thar Desert. These are sand dunes, and that crop you can see growing underneath chickpeas. So you can imagine trying to irrigate chickpeas on sand dunes is technically challenging, and the solution is to use rain guns. So these can be really effective. You don't need a level field. You don't need to lay out your drip pipes. You can bring this in every night if you're worried about theft. Work in South Punjab, we've got really good results from using rain guns for wheat and chickpeas. Another simple, should be a no-brainer, is to actually line your irrigation canals. So here we can see, this is also in South Punjab into Pakistan. We see most irrigation canals are just trenches, in this case just in sand, so it's not surprising that most of the water leaks out. If you can line it with concrete, clearly you can save a lot of water, but that's expensive. And I've often thought about if we could design basically the material we use for pond liners in Ireland, if we could make a simple canal liner out of the same material, but you could simply roll along your canal, your irrigation canal. Another nice example, this is in Burundi, which is catching the water that runs off the roads. This was a win-win. The road engineers were very happy with this, because if you manage the water coming off the roads, you save your roads from being washed away in the rains. So the water from the road would enter a settling tank to sediment out the mud from the road, and then into a rainwater catchment pond, which could then flow into irrigation canals, in this case for irrigating the banana crops. Although most of the Great Lakes area is high rainfall, this part of Burundi, for some reason which I don't understand, is remarkably dry. Conservation agriculture is another way we can conserve soil moisture, but we can also use it to reduce erosion. Here's a couple of photographs I took on a farm we were working on in North Korea. This wasn't with South Africa, this was with Concern Worldwide. I tried to match up two photographs, not perfectly. This is the upper field and the lower field. The upper field was under no-till agriculture. You can see an erosion gully flowing between the two fields, but you can see in the CA field that erosion gully is starting to fill in and recover, whereas under conventional agriculture, you can see the stones in the gully, so the gully is still being eroded. In North Korea, we set up these plots to actually test different tillage practices to see what effect they had on erosion. You can see we put a trench here to collect the sediment and the water. We found in this case in North Korea that maize under normal tillage we were losing 8.7 tons of soil a year, whereas under conservation agriculture we saved 1 ton of soil per year. Another thing we can look at is the crop and variety diversity on the farm. So farmers can grow a variety of crops and a variety of varieties in order to hedge against climate risk. This many farmers have been doing for centuries. So traditionally in South Sudan, farmers will grow 5 to 7 different sorghum varieties in their fields. So they'll have an early maturing variety. So if the rains end early, they'll get a harvest from the early maturing one. They'll have a second early, a main crop, and a late maturing sorghum variety. So if the rains are good, they get all the benefits of a late maturing variety. In Liberia, you'll find farmers planting 5 to 7 varieties of rice. In Niger, which is obviously a very dry country, farmers will mix sorghum and pearl millet. They'll actually mix the seed and plant both at the same time. Pearl millet is extremely drought tolerant. Sorghum is fairly drought tolerant. So if you get a reasonable rainy season, you'll get a good harvest of sorghum. Whereas if it's very dry, at least you get something from the pearl millet. You'll often find many smallholder farmers will have their fields scattered across the landscape. A lot of this is due to land fragmentation, but it's also a way to hedge against your risks. So you may have some fields in the river valleys which can be irrigated, as well as fields on the hillsides and the highlands. So clearly, if we can increase crop diversity, it's a way of ensuring farmers against climatic risks. But we are up against a problem that once land holdings get very small, farmers will really struggle to produce enough carbohydrates from their plot, and they're really unable to allocate, parts of their plot to other crops. And this is something that becomes a real issue because farmers are unable to rotate their crops. They have to grow maize season after season just to produce the carbohydrates, which has other impacts, particularly for weeds and pest build-up in the fields. For livestock, I mentioned the issue of the crossbreeding cattle with Friesian Holsteins. Very difficult to see, go across Africa. It's very rare to find a herd of cattle which doesn't show some signs of a bit of Friesian Holstein in them. But we do have livestock, traditional livestock, which are very resistant to climate change. The caracal sheep, which actually originates in Afghanistan, is the main sheep variety in Namibia, and then the red Maasai sheep from Kenya. The red Maasai sheep are very interesting variety. As you can see, they have a very short coat, which means obviously they don't overheat, and also it helps to reduce the vector parasites. And they're remarkably resistant to homuncus, gastrointestinal nematode. But you can see, if you look at the tail, it's a very fat tail. So this is a breed of sheep that stores all its fat in the tail. So although they're extremely hardy, they'll grow they need very little water. The market doesn't like them. The Kenyan market has moved towards a more marbled meat. So we want sheep meat with the fats mixed in with the protein. So, it's clearly the red Maasai sheep would be a great solution to climate change, but market pressures make it, it's not as simple as we would like to think as agronomists. We have to think about the markets. Similarly, we are seeing herders in Kenya moving from cows to camels and from goats to sheep. In fact, the camel production in Kenya has gone through the roof, and Kenya is now the world's third largest camel producer. But it's not without risks. Most of you will have heard of MERS, which is the Middle East respiratory virus, which is transmitted from camels. So obviously public health authorities in Kenya are now extremely worried about the MERS risk from the increasing camel population in Kenya. So moving on to conservation agriculture, something I've done a lot of work on in the tropics over the last 10 years. So it's called no-till in many countries. Three basic principles: avoid disturbing the soil. So this obviously reduces the erosion, the water erosion, the wind erosion. You can do this using rippers, direct seeders, or by hand through jab planters and zai holes. Keeping the soil covered to reduce evapotranspiration and evaporation from the soil surface using mulches or cover crops. And then just general good agricultural practice, rotate the crops. So in the conservation agriculture projects I've been working on in Southern Africa, in Malawi, we'll be rotating the maize with groundnuts, which is a cash crop. It's also a nutrition crop and a nitrogen fixer. With soya, also obviously a nitrogen fixer, but a very good alternative cash crop to tobacco. Tobacco being the main cash crop in Malawi, but it's declining, and even the big tobacco companies are starting to move out of tobacco. In Zambia, also rotating maize with groundnuts, but also bambara nut, which looks like a groundnut. It's actually completely different species, but it's a very hardy variety. Cowpeas are produced across Africa. This is an amazing crop. You can eat every part of the cowpea, so you can use the leaves as a vegetable, the flowers as a vegetable. You can eat the pods green. You can eat obviously the cowpeas when they're dried. And I've even met women in Zambia who use the roots for flavoring drinks. And in Zambia, using sunflowers as a cash crop in the rotation, and Zimbabwe rotating between maize, cowpeas, and sorghum in the low belt, which is the dry areas of Zimbabwe. So in terms of not disturbing the soil, so how to plant without disturbing the soil, I'm sure, obviously, I don't need to talk about mechanized agriculture to you. You all know more about mechanized agriculture than I do. So I've moved straight on to sort of ox-drawn and hand operations. So here's a simple ox-drawn ripper. You can convert a traditional ox plow into a ripper. You simply remove the moldboard, you put two wings on to stabilize it, and a ripper tine. Really, really fast. You basically have to run to keep up with the oxen. So you can prepare your fields very fast, which reduces the cost. And of course, the problem you have with animal traction in the tropics is at the end of the dry season, your oxen are very weak because they haven't had a lot of high quality feed. And so they do struggle to plow, and plowing takes a long time with oxen, whereas with a ripper, the energy requirements are a fraction of the requirements of more mobile plow. So even with weak oxen, you can prepare your land. The Brazilians have really led the way in terms of producing equipment for smallholder conservation agriculture. So this is a fertility planter from Brazil. This is an oxdrawn planter. You have a knife blade in front, which will cut the trash, a ripper tine to open up the furrow, fertilizer and seed here, and then this wheel will drive a mechanism to for the seed and the fertilizer bins. This is the Napic, also from Brazil. This is kind of the Ferrari of ox-drawn direct seeders. In order to reduce the import costs, this is a Magoya planter and ripper developed in Zambia. It's a similar idea, but all made from locally available metal to keep the cost down to the sort of $100 a ripper mark, which is really the price point for Zambia. If you don't have oxen, and of course a lot of farmers won't have oxen for various reasons, here's a hand seeder, the jab planter. Again, the best stuff all comes from Brazil. So this is the Fertility jab planter. It works like a pair of scissors. You open and close it with the fertilizer in one side, seed in the other. Again, like everything in this in the world, the Chinese have cottoned on to the idea and have now taken the Fertility idea and converted it. So these are Chinese jab planters being used in North Korea. And this is from Professor Li in China. He looked at the traditional hoe used in Africa, and he's developed a tool that looks very similar to the traditional African hoe. You use it in the same manner, but every time you bring the hoe down into the soil, there's a click, and you have a sack here with your seed and fertilizer, one time for the fertilizer, one time for the seed. So farmers can use the same sort of muscles they've been using with their hoe in order to use the lice seeder.
Well, we have about 2 minutes left for the presentation.
Right. Great, so I'll just do the last one, and then we'll go on to questions. So, and finally, this is a technology that came from Burkina Faso and Niger, which is the Zai Basin. So these are just little scrapes, are only 15 centimeter deep. So you can prepare these in the dry season, and then when the rains come, you're ready to go. So you can put your fertilizer, your compost, and your seed in the basins and the first rains. And then you're ready to go. And this means you're planting early, and means your crop has a much greater chance of maturing in case the rains end early. So these are examples from Zimbabwe, and here's a group of ladies who are helping an old lady who was no longer able to prepare her own Zai basin. So they're very fast. This was a 50 by 50 meter plot, and they prepared this plot in about an hour. So I'm happy to stop there and to take questions from the audience.
Okay, that's great, Paul. Thank you very much. Fascinating presentation. Really great insight into the work that you're doing in Africa and in other in parts of Asia as well. Obviously, there's a lot of things you talked about there that have relevance to Ireland. But I mean, in terms of contrasting the two systems of European agriculture and agriculture in Africa, sub-Saharan Africa, you know, what do you think are the key lessons or issues that we need to be conscious of here within Europe, you know, in terms of adaptation and preparing for the likely changes in our climate?
And I guess we will also have to think about the impacts of increasing CO2 levels on our crops. You know, how is that going to change the nutrient levels in our crops, whether it's for animal feeds and or for human consumption? So certainly that's a factor. And the little research that I've seen that has been done on CO2 levels, for example, in maize, has focused on maize as animal fodder rather than humans. So certainly CO2 levels will have an impact on the nutritional value of our own crops.
Yeah, because you showed a very interesting slide there with the Fedherbia tree there fixing nitrogen. You know, we're living in Ireland, so there's a huge emphasis on reducing nitrogen within agriculture across Europe. And I think there's a lot of lessons that can be learned there from the development work that's going on there. Look, I don't want to sound self-serving here from a European perspective, because of course a lot of the emphasis here is on what we can do to support the work that's happening in Africa through Self-Help Africa. I mean, just in terms of the key priorities for Self-Help Africa, I mean, a lot of people looking on today will be looking at, well, what can we do in Ireland, or what can the Irish agri-food sector do to support the efforts of Self-Help Africa? What are the key challenges there from your perspective that you feel that there could be maybe better engagement?
Well, I mean, obviously we have the corporate social responsibility angle of it, and also when we have the technology transfer. So technology transfer, yet clearly there's a lot of very interesting technological developments in Irish agriculture, and we've been working with Teagasc to try and take some of the research and the technology from Ireland to Africa. So for Teagasc, working with Teagasc, we have a joint dairy project in Kenya, which is working with the linking Teagasc and the Kenyan Agriculture Research Institute to basically take the learning from the economic breeding index that's been developed for the dairy cattle in Ireland and applying that for Kenya. Again, with Teagasc and Sustainable Food Systems Ireland, we're now doing a consultancy for the Irish Embassy in Uganda, which will again be looking at how we can link Irish institutions with Ugandan institutions to share learning and technology. And again, we have a similar project in Eritrea. So that's on the technology transfer. In terms of the corporate social responsibility, I'd like to plug our link with Glenisc. We have a great project going with Glenisc. So you can either go onto the Glenisc website or to the Self-Help Africa website. So with Glenisc, we're planting trees in Ireland and Africa. So if you pledge €5 on the Glenisc site, that will help to plant one tree in Ireland for every 10 trees you plant in Africa. And if you buy Glenisc yogurt, and I hope I'm allowed to do commercial promotions on this video. So for each pot of Glenisc yogurt you buy, that'll donate 50 cents towards tree planting in Africa. So we're looking, obviously, planting trees to try and absorb the CO2 we're producing around the world. And we are talking to other corporates in Ireland about expanding the tree planting program.
Yeah, I encourage anyone to have a look at the Self-Help Africa webpage, because I also see that you're doing a 40-day walk as well for Lent, that people can raise some funds as well that way. So that's a really excellent idea for people who are in lockdown and want to get some exercise in within their 5K radius, of course. Pat, some interesting questions coming there from all different perspectives.
Yeah, some very, very questions. I suppose a common theme in some of the early questions: how do you define smallholder agriculture, or not so much define, but describe smallholder agriculture? What's a smallholder?
Well, it'll depend on which agroecological zone you're in. So, but typically we're talking of somebody who has really less than 2 hectares of land. Although in somewhere like Malawi, if you have half a hectare of land, you're the richest farmer in the village. So it is very small land holdings, not mechanized. So for example, for Southern Africa, we tend to define smallholders, emerging farmers, and commercial farms. So the commercial farms will be the sort of 5,000 hectare, fully mechanized farms. The emerging farms would be the farmers of the sort of the 5 hectare who can invest money in mechanization and new seeds, and the smallholders is the less, the 2 hectares and less.
A question there in relation to the records. Are there any good long-term records over the past century to actually show the impacts of climate change on weather in Africa?
A very good question. It is challenging. Obviously, formal records only began with the colonial period. So, for example, for Kenya, during the colonial period, we do have good rainfall records. So for Kenya, it's good. Uganda, we have a big gap in the records during the sort of the Idi Amin period, when people had more important things to worry about than measuring rainfall. And of course, in other countries, we have very little in the way of rainfall records. But we do have an interesting project with UCD. We have a postdoc student who's examining stalagmites and stalactites from caves in southern Africa. He's doing isotopic analysis of them to try and understand rainfall patterns in southern Africa, sort of pre-paper records.
There's quite a few questions around kind of the sustainable development goals, around gender equality. How are those various themes that come from, I suppose, the SDGs embedded in your programs?
Gender equality is hugely important. Again, we could do a whole webinar on this one. Very many factors. It's what's the differences between men and women's role in agriculture. So women will traditionally be doing things like the weeding, the planting. Men will often prepare the fields. Now, for example, if there are oxen involved or mechanization, then preparing the field will be a man's job. If it's handwork, it could be a woman's job. So if you can mechanize agriculture using, say, small tractors, the sort of monoaxle tractors, possibly that will reduce women's workload, because preparing the fields or doing mechanized weeding will now become the man's job. We have differences in crops. So groundnuts, peanuts in much of Africa will be the woman's crop. Maize will be the man's crop. We do have the concern that if groundnuts becomes commercially interesting, will men take over women's responsibilities for this? For the dairy sector, although men will traditionally own the animals, pretty much every country, women control the milk. They milk the cows, they process the milk, they sell the milk. So we have to be very careful when we're doing dairy projects that we don't take control of the milk value chain away from women. We also need to look at things like inheritance. Across most of Africa, it's patrilineal inheritance, so it goes from a man to his sons. But we do have areas in Africa where it's matrilineal, so it goes from the land is inherited by the daughters, which doesn't necessarily mean women are in a better position, because their husbands feel, well, if I ever get divorced, I lose everything. So I'm not particularly enthusiastic about investing in the land.
Yeah,
so it's complicated.
Yes. That translates across the world, I think.
Yes.
And Paul, a few questions coming in relation to the appropriateness of sending Holstein Friesian animals to these parts of the world. In light of what you've talked about there, how the climate, how suitable is the climate for that type of an animal?
Well, the highland areas were suitable, but one of the challenges, as I mentioned in my slide, is, say the highlands for Kenya, highlands of Ethiopia were tick-free, for example. We're seeing ticks moving up into these highland areas, and that's obviously very challenging for Friesian Holsteins, which have very low resistance to tick-borne diseases. And as I mentioned, the heat stress issue. Most farmers would actually be crossing using AI. But I still have some concerns over, crossing with Holstein Friesians, and this is why things like the research we're doing with Teagasc in Kenya about the economic breeding index is looking at different crosses and the economic values of different crosses. And again, as Pat mentioned, the gender issue. Talk to the women. What traits are the women looking for? They're the ones who have to milk the animals. And when I've done this kind of survey in Ethiopia, not surprisingly, women actually said we're actually more interested in Jersey crosses, because the women have to carry the fodder to the animals, the women have to carry the water to the animals, and the women have to milk them. So they were much more enthusiastic about a docile animal, but didn't try to kick them and didn't need as much water and fodder.
Of course, yes.
Again, an interesting one for Ethiopia during the for fasting periods, people can't consume animal products. So Jersey milk, high cream content could be turned into butter that could be then stored until the end of a fasting period.
Okay, so really practical issues there. We have a question here. It says, Paul, in the future, do you think agriculture will prosper more in some countries or regions if climate continues to change? Or if so, will some populations start to move in response to those changes?
Well, depending on which academic you read, that's already happening. Many academics will talk about sort of climate refugees and climate, wars, conflicts due to climate. I actually find it's a very complicated thing, and it's, tendency to oversimplify. We do have examples, for example, in Kenya, areas of Maasai land where actually the rainfall is predicted to increase. And there we could see rangelands being converted to maize production, which may or may not be a good thing. It could lead to more conflicts between herders and farmers. What we are seeing is really the middle classes investing in agriculture, and this is a trend across Africa. Middle classes living in the cities with salaries are investing in land back home, because they have that capital to invest, but also very much because they're linked into the information economy. They're the ones who can surf the internet and learn about what Teagasc is doing in Ireland and think about, well, can I apply this to Zambia? So we are seeing changes, particularly in Zambia and Kenya, of it's the middle classes who are tending to invest in agriculture in rural areas.
A couple of questions there. Are there problems with seed availability and distribution?
Absolutely. That's one of the big areas for Self-Help Africa. We, as an NGO, we would promote a pluralistic seed system. So obviously you have the big seed companies, but we're working a lot with farmers, particularly for cooperatives, which are producing seed. So we have very large seed producing cooperatives, which have come together to form cooperative unions in Ethiopia. We're talking, which now supply a significant part of the seed sector in Ethiopia. So through COPT in Ethiopia, we are producing a lot of the seed that's required on the Ethiopian market. Similar projects in Zambia, though, through sort of farmer-owned enterprises rather than through the cooperative system. But the challenge is, and it's not just small, the work we're doing, it's a challenge for everybody, is the early generation seed. It's getting enough seed from the researchers, from the breeders, to then multiply on the seed farms. And that's really the challenge, is how do you boost the production of early generation seed in order for the seed producers to satisfy market demand.
The question here, and it kind of, I suppose, opens up a bigger discussion in terms of approach. Are you looking for people to work on projects? But I think it alludes to the question of the approach of enabling the systems and the people within the countries to be their own development agents. And I think that's part of the approach of Self-Help Africa.
It is. So we tend not to employ expatriate staff unless they have specific skills which are not available locally. So our European staff will all be based in the European offices. So there's a couple of exceptions in particularly specialist areas, but as far as possible, we recruit locally. But certainly, what we're doing a lot more is research collaboration. So we are collaborating a lot with researchers in Irish institutions and other European and US institutions. So we do have opportunities for early career researchers. So that would be an opportunity rather than actually working as sort of expatriates overseas.
I suppose one final one there. What adverse effects can food aid have on agricultural production?
Okay, humanitarian work is a very small part of what we do, but it will expand. It can have a hugely detrimental impact on local agriculture. So like most NGOs now, particularly in the humanitarian sector, we're trying to discourage food aid. We're trying to move towards providing cash. If you can provide cash to people in an emergency, in a crisis, they can then use that cash to buy food, and the market will generally respond and provide the food. Now, it's not always the case. You can have cases where people are cut off by floods or by wars, who will still need the classic convoy of UN World Food Programme trucks. But actually, those situations are relatively rare. We have in Malawi, for example, very different agroecological systems between the south and the north. So when it's a drought in the south, it's usually, have good rains in the north. By providing farmers who have no food in the south with cash, that stimulates the local market. So traders will then purchase crops in the north and transport them to the south. So we are, and most NGOs are moving towards cash, or if not cash, then at least vouchers, to try and stimulate the local economy rather than providing food aid, which often kills the local economy.
You mentioned in your presentation, and Mark's looking at me saying we're nearly finished, the focus on markets and market access for smallholders. How important is that in your work?
Okay, for South Africa, we will consider farming to be an enterprise. It is a commercial enterprise, and I know other NGOs would disagree strongly with this position, but we feel in the 21st century, if you're not making enough money out of agriculture, there's something wrong. Okay, it's obviously the same issue for Teagasc in Ireland. People have to make a decent living, a fair living out of agriculture. So that does mean linking farmers into value chains and supply chains. It means making sure that farmers can access the inputs they need. The choice of inputs, again, for instance, seed, we see a pluralistic seed system where farmers are allowed to save their own seed, exchange seed, if that's what they want, or to go to the local agro input shop and purchase seed from whichever seed company they want to. We are not saying we don't want to drive the commercial seed sector out. We see there's a strong role for them. And in fact, what's very exciting in Southern Africa is the number of seed companies which have started up. 10 years ago, we all assumed the seed industry would be dominated by Syngenta and Monsanto, and actually that's not the case at all. Malawi now has over 20 different indigenous seed companies. So it's all about building up local enterprises, both for the supply sector and the utilizing the products that are coming out of our farms.
Okay, Paul, I'm afraid, and Pat, I'm afraid we're going to have to wrap it up there. As much as I'd love to continue the conversation, we try to wrap up the webinars, try to keep it within the hour, because we know that people have other commitments. Paul, if somebody wants to get involved or reach out to Self-Help Africa, what's the best way to do that?
Okay, if you look on our website, obviously you can contact us through the website. We're trying to add to the list of technical publications available through the website. So our library is slowly increasing. So the best way is through the website, or through yourself. You can forward emails on to me for anybody from Teagasc. I'm also happy if you can save the questions that people have posted. Yes. I can provide answers to those.
We can do that for sure.
I can see some very good questions here.
Yes, absolutely. Yeah, very intelligent questions coming through this morning, so thought-provoking. Look, we will wrap it up at that. Thank you so much, Paul, for that enlightening presentation. It's always good for us to look at what's happening in other parts of the world and lessons that we can learn and vice versa as well. So we will certainly keep in touch with you, Paul, and maybe we'll have you back again to give us another update in the future. Pat, thanks for helping with the questions this morning. And I also want to thank our production team, Andy Boland, Catherine Keena, Pat Murphy, and Yvonne Maher, who are organising all of the talks in the background and doing all the hard work. And just to remind you as well, you might have seen at the intro, there's a conference or a webinar taking place next week, the 3rd of March. It relates to the use of legumes within agriculture and how legumes can reduce nitrogen within the agricultural systems. So that's takes place online on next Tuesday, I think it is, the 3rd of March. And so you can log on to that or register for that through the Teagasc website. So finally, thank you for tuning in this morning, and we do hope you have a nice weekend, and thanks again for watching. So we will talk to you next week. Next week we'll be joined by a representative from Carberry, who's going to be talking about their journey around sustainability. So we look forward to that. So thanks again.